Okay, so here they tell us that on this coordinate plane, a dilation about the origin, and remember they're referring to when they say the origin, right, or the origin, it's just referring to the point 0, 0. So in this case, we're dilating about the point 0, 0, which means whenever we dilate, we're increasing or decreasing a point's distance from that origin, right? So it's all in reference to this point right here. And they're telling us that you're going from figure A to get figure A prime. They want to know what's the scale factor and how does this alter the area and perimeter. So an easy way to deal with this is just to look at any corresponding side and realize that if this length is 2 and its corresponding length over here is 1, and vice versa, this is 2 and this is 1, and you can calculate these as well, but here if you see corresponding sides are reduced by length in half, that means your scale factor is 1/2. So that means, right, the scale factor, right, equals 1/2. And so essentially what you're doing is comparing corresponding side lengths, and that way you can find the scale factor. If you reversed it from figure A prime back to A, the scale factor would be 2. So whenever you have a scale factor between two shapes, if you go the other way, all you do is take the reciprocal. Meaning here we go from the larger to the smaller, that's 1 over 2. If we reverse it, you get 2 over 1, the reciprocal of 1 over 2. So there's that nice duality there. Also, you can just look at an individual point. For example, here this point is at 4, 2, and its corresponding point is right here. And what's that point? Well, that point's just 2, 1. So now, by looking at just a single point, and this is a rigid motion, so whatever one point is going to be doing, the other points will follow. We go from 4 to 2, and from 2 to 1. And that means the scale factor is half because both x and y, the 4 and the 2, are multiplied by a half to get 2 and 1. And again, with dilation, first you have this distance out here and to the origin, and then when you dilate it by half, you reduce that distance, right? You have a new point that is half the distance from the origin here. So you're looking at this chunk now. And that's what's happening with dilations. You're reducing or increasing a point's distance from the origin. Now, how does this affect area and perimeter? Well, if each side is half, then the entire perimeter is going to be half, right? If you had a shape, let's say it was 2 by 2 by 2 by 2, well then the perimeter would equal what? 2, 4, 6, 8. If you reduce each side, right, by, or multiply each side by half, you get 1 by 1 by 1 by 1, which is 4, so your new perimeter becomes 4, which is half of the old one. So the scale factor is a half, the perimeter is 1/2. And it's just a similar example. The area, however, behaves differently. You can almost see it here in the picture. If you reduce each side by half, really what happens is the shape becomes 1/4 of its original size. Right? So here if the area is 4, here the area is just 1. And the idea is that the scale factor squared is how to track the changes in area. So we have this idea when you're dilating by a scale factor of 1/2 any point x and y, right? What's going to happen? Well, it's going to equal 1/2 x and 1/2 y, which is what we're discovering here. But also, if k is your scale factor, right? Then two things happen. Then perimeter becomes k times longer. That just means take your new perimeter of your new shape, multiply it by the scale factor, and that's how many times larger or smaller than the first. You take your first perimeter, multiply by your scale factor, and you will get the new shape because it's that many times smaller or larger, right? It's k times longer or shorter. It's directly related. But if k is your scale factor, right, the area, I'll say changes this time to be more efficient, by k squared. Right, so if you have an original area and the scale factor is 1/2, the new area is 1/4 of the original. If the scale factor is 2, you square it and your area becomes 4 times larger. And again, I was trying to show it up there, but I'll show it as well here. If you have a 1 by 1, right, square, and I double each side, you can see that what's got to happen is, if this side doubles, and so does this one, we're doubling both sides, right? And we double each side, overall, your shape becomes 4 times larger, right? When you find area, you have to multiply your length and width. So if this side is the original times 2, or 1 times 2, now this side is also 1 by 2. So you've multiplied by 2 effectively twice if your scale factor, if k equals 2, right? So you go from your original area 1 by 1 to this new area, which is 2 by 2 or 4. And again, if the scale factor was 3, it would be 9 times larger. If it was 4, it would be 16, and so forth. Just the scale factor squared times the original area gets you your new area. Alright, hope this helped.